I am very, very excited to have my very good friend Sally Slade join us on this for this next talk. Sally is an incredible person, one of the people that I admire the most. She is absolutely wonderful. The only person I think that is loves her more is my daughter because my daughter is extremely inspired by her as well. But she is an incredible person that I worked at a Digital Domain back in the day and has done incredible things in develop beyond that in the AR and VR space, and is now co-founder over at Voltaku. And I had the pleasure of working with Voltaku for actually a couple of years on trying to tinker around in the virtual production area. And Sally and I had sort of were working together on some interesting things. But I think what would be cool is for Sally to give you guys a quick talk about what's going on at Voltaku. What is Voltaku? What is it as a company? What are they trying to do? They're a very different kind of startup. And then why virtual production is important. And then, of course, why I started talking to them about the cool stuff that I've done, which will lead to what I've done in the last couple of years. And I can finally talk about that a little bit more. So, Sally, go ahead, take it away.
Oh boy. Okay. Thanks for having me, Chris. This is going to be fun. I have prepared a slideshow, so we will give that a try. Um, let's see. Share screen.
There you go.
Do it.
Do
Do
it.
it. Okay. So here we are. Hello, it is I, Sally of Voltaku. Voltaku is a real-time animation studio. We are creating cross-platform stories for the otaku audience. If you're not familiar with this word, it means an obsessive fan, typically of something like Japanese animation of anime. That's how we identify, but you could also be an otaku for fly fishing. So we are making a we're making some content for this beloved audience who grew up on anime and is now completely underserved. Otaku don't have a dedicated studio in North America that's just like trying to give them some content now that they're grown up, millennial Gen X type people. What's out there for them? Not a lot, at least not domestically from the US. So we have licensed this comic book series called Killtopia from these two dudes in Scotland. They've made this really vibrant cyberpunk world. This tells the story of a brother and sister as they navigate a nano plague and try not to die in like this totally messed up version of Tokyo. Um, and they encounter like quite the colorful cast along the way. So of course we want to make this into a TV show, yay! And we intend to do this using virtual production workflows because if we use this kind of real-time animation and game engine stuff to make this show, then of course we can share assets with some kind of metaverse pipeline so that we can have real-time animation for things like VTubing with our fans and community, or hopping into VR chat, or any of the like very exciting emerging metaversey things that are out there. And of course, we'd be able to share those assets, so we'd only have to make them once, which is something we're excited about. And part of the reason why we wanted to pursue this idea of here's all our cross-platform goodness. Why we wanted to pursue the idea of real-time ray tracing because we are coming from a visual effects background, so we're very accustomed to a ray trace workflow. Plus, we love the idea of doing real-time ray tracing on set so that we could kind of get this idea of what a final frame might look like as we were shooting the thing. And we had a lot of help with this experiment. We made an incredible proof of concept and prototype throughout last year, with no small thanks to Chaos, who really helped us drive this forward. And of course, NVIDIA was in the mix, Epic, Xsense, Lenovo, Foundry, and some assets from Kitbash as well. So thanks to this Avengers team assemble of excellence, we were able to make this very cool real-time ray trace prototype. We got up to 12 frames per second at that time. Those were ancient times. We've got much faster machines now, even just a couple months later. And that was with deforming meshes and stuff. So pretty exciting and impressive work we were able to do, and we love that we were able to push the envelope while pursuing this very cool kind of nerdy sci-fi goodness. So I'll tell you a little bit about what we're up to now that we've kind of hit that milestone. We are bouncing back to look at our tech stack. So we're currently working on an avatar maker, which is open source. We're kind of capitalizing on this PFP stuff that's happening in the NFT space. We want to make our Killtopia avatars based on the comic books. We've created software to help us do this, which we're really excited to share with the community. It doesn't only work for our project, it can work for any project that's up and coming in 2D, and we can retrofit it onto projects that already exist. Here it's retrofitted onto a project called Galverse, which is a very cool otaku brand about these space cadets bringing peace to the universe, which Killtopia desperately needs. And part of what we're doing with this avatar maker is we're defining a universal avatar descriptor file, a UAD, and it's not what you're thinking. It's not a USD GTLF alternative. It is a high level JSON format that just identifies things like, hey, she's got pink hair. It's parted to one side. She's got two ponytails and a red formal attire. And using these kind of high level descriptions, we're able to map between avatar systems. You can see on the right, we've got a Galverse NFT, and on the left, we have the Killtopia kind of equivalent. And we're very excited to kind of do this across projects and kind of create this first layer of interoperability that we're also excitedly seeking, with our sort of metaverse dreams. So we're very excited to be collaborating with a few projects on this and build it into our open source tech stack. So yeah, this is all going to be in service of our 2D avatar pipeline, which is going to be real-time animation VTubers. We're super excited to procedurally rig these and release them, and start our VTubing journey with our Killtopia XYZ project. This initial 2D project is kind of like homage to the comic book, and we hope to use the revenue from this NFT drop to get these key hires going so that we can have our sort of 3D virtual production pipeline up and running and make that TV show. So yeah, that's kind of the long and short of it. And that's what we're up to.
That's awesome. And I've been obviously a big fan of Voltaku for many years. And you and Charles are incredible people that are creating, really have very great ambitions. And I'm totally 100% behind supporting you guys. But I did take the opportunity to work on Killtopia with you guys so that I could really see how far we can push the virtual camera stuff. So I'm going to go ahead and share my screen. Let me go ahead and do that. Let me see. Slides. How do I Google slide? Uh-oh. I have to do this. Hold on a second. Give me 1 second. I realized I didn't do this ahead of time. Okay. Is it working now? Let me know. Sorry about that, Teddy.
We'll get there.
We'll get there. Okay. Is it sharing? Yay.
Yay.
Okay, so you guys are seeing this. So do I click on this? Oh, okay, perfect. All right. So what I want to do is really, I got obsessed about developing a fully ray traced virtual camera and seeing what that actually means and what it means. And so where did that come from? So here's what I'm going to talk about real quick. I'm going to talk about Chaos Labs and virtual production and the origins of that, which is actually quite long. Ray tracing, the difference, the opportunities that ray tracing has to do when we're doing virtual production, and then virtual production today and how it's changed from when I first started this, and then obviously what that has all come together for the Killtopia proof of concept and what we were trying to do there and sort of the process we did there, and then what I'm sort of going from with that and beyond. So the first part is I want to talk about Kevin Margot's construct. So I know some of you may have known about this, but some of you may not. So I might as well go through a little bit of history here. So this is back in 2013, and I just literally almost just started working at Chaos Group, and Kevin had asked to be able to do this short for something called Construct, and he wanted to get some help from Chaos. And we were totally willing to do that, but we had some new technology we wanted to test at the same time, which was a perfect opportunity for labs to test this stuff sort of in real life, right? And so it was a perfect storm of technology at that time. So we had just developed, brought our V-Ray GPU rendering, which was originally developed and originally came out in 2008, but by 2013 it had actually gotten really robust and was able to pretty much create a feature rich system that could do final frames. At the same time, NVIDIA had just developed their K6000 GPUs, which were the first GPUs to have 6 gigs of RAM, which now does not seem like a lot, but back then it was enough to really do a full frame of rendering. And then at the same time, we also developed something called V-Ray App SDK, which allowed us to wrap V-Ray inside of any application in a lot of really cool ways. And so when short story is basically we were able to render everything on GPU, but then Kevin said, "This is going so fast. Can I do it for motion capture?" And because we had the app SDK, because we had V-Ray GPU, and because we had these actual GPUs, we actually brought V-Ray inside of Motion Builder, which is what the motion capture systems were used at the time. And then that's when we decided to really see what's possible. And so what happened when we looked at that, we started to see the advantages of ray tracing during motion capture. And there are three key things that we figured out that, through this experiment, which honestly we didn't really know if it would be useful or not, but by actually doing things and trying things, we actually found three key advantages to doing this during ray tracing during motion capture. One is you only have to look dev it once because you are going to be using V-Ray shaders in the final frame, but you can use them in the pre-production and the previs as well. So you can use the V-Ray shader the entire time, and look development only happens once. Because before that, you'd have to look develop it for V-Ray for the final frame, but you also had to get a version that would work for the rasterized rendering of Motion Builder at the time, which is kind of can be a pain in the butt sometimes. The other thing that was interesting is there's a lot of things you do in rasterized renderings that are hacks to make it look better than it can actually look naturally. So with doing full ray tracing, you don't have to do any of those hacks. You don't have to do reflection spheres. You don't have to do shadow maps. You don't have to do all those other hacks. You just ray trace it the way you would normally ray trace it, and it would work. Uh, and the other advantage we also saw was that basically what you're actually seeing was much closer to the final frame than it needed to be. So than it was before. So you didn't say, I guess that's going to way it's going to look. You can actually say, no, actually that's pretty close to what it's going to look like. And these are what we're doing. Now you can see in this example in our very early experiments, it was very grainy, but it's still enough to give us the information that we needed. But that's the whole point of labs is we try things way before they're ready for prime time. Okay, so let's skip to virtual production today. And so what's happened since then, there's a lot of changes that have happened. So first of all, the arrival of game engines. Game engines have completely revolutionized what virtual production is. Now, there's different classes of virtual production I'm talking about. There's two main ones we talked. One, we talked about LED walls, which some people don't actually call virtual production. They call them in-camera VFX, but we talked about it on our previous talk. And the one we're talking about now is more traditional motion capture visual effects. So let's talk about more like Avatar in some ways, right? So that's really what I'm talking about. But game engines have been introduced actually in both of those situations to sort of introduce things. And that's kind of changed everything and enabled people to do a lot more things and experiment actually honestly with a lot more things, which is very interesting. The next thing is hardware has gotten a whole lot faster and software has gotten a whole lot faster. Both of those things combined means that what I was doing in 2015 on Construct, I needed 3 VCAs. That is 32 of the highest end GPUs they had available at the time to get about 30 frames a second. Well, it's probably closer to 24 frames a second of performance. I can do that exact thing today in 2022 on the laptop. In fact, this laptop right here. You can see it right here. There, it's right here. It's very hot, but it's still pretty good. But this laptop can do the same performance, if not better, than people could do using pretty much $1 million worth of computers here. I don't know if it's actually $1 million. It's quite a lot though. Anyway, um, so I thought this is perfect. Let's start building out. Let's do things with Killtopia and talk to Charles and Sally and says, let's see what we can throw at this thing. So we did it. We shot this. We shot the sequence, the proof of concept, actually in my backyard, believe it or not, and we worked on trying to figure out what we could do. So the first thing we had to do is we used V-Ray for Unreal and we used Vantage. Those are the big tools that were important for this transition for the real-time ray tracing inside of this. So the first thing we did is using V-Ray for Unreal, all of the assets that were created in other packages with V-Ray, so in this case was Maya, all of them could be imported inside of Unreal, and all of the V-Ray shaders came with them. What V-Ray for Unreal does is it creates a representation of that image or a representation of that shader that can be seen in Unreal so that you can get a visualization of the textures and everything generally working, but also allows it to keep the actual V-Ray shaders. So the V-Ray shaders are still connected to the entire system. And so when rendering with V-Ray, it'll all look exactly like it was done with V-Ray. The problem is bringing in the way that's brought in is currently it's brought in as a V-Ray scene file, and V-Ray scene files do not bring in things like the rig itself, right? So if you have a character rig, in this case, our fabulous character Stiletto, she was not able to be brought in for the V-Ray scene file. So we actually brought her in through the traditional FBX pipeline, and then that was able to get all the rigging information in there. And then I just copied the shaders over inside of Unreal, the V-Ray shaders over to her, and that worked just fine. Now, the other cool thing we're able to do is like, okay, you can render in V-Ray, but with Vantage, you actually have the ability to do live linking. So I was able to actually use V-Ray for Unreal, and instead of rendering to V-Ray, I used a live linking to Vantage to see how fast we could actually get the motion capture to happen and then actually be able to move a camera around and do complete ray tracing at the same time. Now, the big difference between Stiletto and the construct robots is the construct robots were actually non-deforming geometry. They just had joints. So the translation of data that's going in the live linking process is actually pretty fast because I'm only just moving a few transforms around. But with Stiletto, her entire mesh is changing with every frame. So there's a lot more data that has to be translated in the live link process, but we were still able to do that. So that was kind of the experiment that we were really experimenting with. Now, this is completely cutting edge stuff to the point where like a lot of things that we did, we didn't know if it was going to work or not. And it works pretty well. And now we're just trying to make it a little bit better. I'm just gonna give you a little bit of that. So where do we go from here? So, as I said, I am actually very excited about trying to figure out how to make a virtual camera as close to a physical camera as possible. So, I actually built one that does exactly that. So, I want to give special thanks to my good friend Justin Denton, who's actually doing similar things, and he gave me a lot of hints. And he gave me his Amazon shopping list to construct all of this stuff. And so, I built this entire camera for about $700, right? And to get it all working here. Now, what we got here is we basically got, the general frame armature of the camera that I want. I've created a monitor here that is using a Miracast thumbnail here or thumb connection here that basically uh, mirrors what's going on the computer. So I can basically see what's going on here. And then I also have a Vive tracker. Obviously, all the tracking is happening here. And then here, I've got these two little cheap Bluetooth controllers that I've basically emulated to be an Xbox controller, and I'm able to reprogram these in Unreal to do whatever the heck I want, right? And so with that, what I'm able to do is I'm able to take this camera and I'm actually able to turn all these controls so I can do focus pulls, lens changes, f-stop controls, exposure controls, and all of those things so I actually can see what it's like to use an actual camera. That is basically what I'm very excited about. So I made this video, and I'm not kidding, just probably about 2 days ago, and we're still working on better versions of this, but I thought it would be exciting to share it with you guys soon. So please, Teddy, if we can play the video, and I will be able to talk over this. All right. So here I basically moved the camera up and you can see how the camera is moving around, and I'm able to change focus. We actually have an autofocus, which actually shoots a ray at whatever's in center of the screen, and then it'll focus on that aspect. So that's kind of a cool new aspect. So I'm looking at this light here, and this here, you can see I'm probably getting about 50 frames a second. That's because I don't have my character in here yet. But Vantage is actually live linked to Unreal here, and I'm moving my camera, and it's getting the data from Unreal and looking at it in Vantage, and I'm able to move around. So I'm changing the exposure here, and I'm looking at what it's like, and obviously the exposure is too bright here, so I'm going to go ahead and dim it down, which is really great. I got these quick buttons, so I could just change f-stops and exposure. And here I'm going to change the focus to this foreground. Oh, I love it. It's like a real camera. It's like a real camera finally. And I actually have the data up here. If you guys are checking out the video, you can see that I can change the f-stop. So now I'm going to bring in Stiletto and see what she looks like. So what I've noticed here is that when our denoiser that we have built in that you saw previously doesn't actually look that great with a moving character. So I went ahead and turned it off so that I can look at her with the noising off. And I find that even though she's slightly grainy, I'm actually can see a lot more contrast and color in her. So I actually like denoising off in this. But it's a good incentive for us to sort of look at our denoiser and see how we can improve it based on some of these situations. I'm also looking at, like, I want to see, what it'd be like to shoot her at an F1 video or F1 stop here. And I can see the challenge. The minute she moves forward, she comes out of focus. So this is why you need an onset focus puller. I know that trick now. Always get a focus puller if you're going to do that. But it was really is sort of seeing, all of these different things. But I'm able to capture the actual, lighting that I want and see it the way I want it. And I know that the way that this is going to be lit is going to be much, much closer to the final frame compared to what I would do if I had traditional rasterized rendering. So really exciting to show you guys that. And thanks. We can stop the video here. Uh, and I think we can go to, questions and see where you guys are. So uh, Lon or Melissa, I'm not going to ask questions because but if you, let's know if you guys have any questions. You're muted, Lon. I'm waiting for that one.
Ah, here we are.
Bingo.
It's light.
It's awesome to see that come together. I mean, I know you guys have been working really hard for a while to do that, and every time that I check in, it gets better and better and better. It's, I mean, we've been talking about trying to have that sort of camera control. I love that Justin just shared his Amazon list and was like, "Here you go, put it together and MacGyver it." It's just awesome stuff, and I can't wait to see where it goes from here.
Yeah, I mean, it's a matter of like, oh, this works, and I just, first of all, I just want to thank that guys at Voltaku for sort of allowing me to play in their art, right? Like, it's like I got some stuff I want to play with, and I want to make this work, and this would be really cool to do that. And I think that I've been following the Killtopia series and what they're doing, and I'm sort of been excited to see that. So I definitely should check them out. And you guys should totally go to voltaku.com and check out all the amazing projects they're doing, including Sally's avatar stuff. But I think there's a lot of interesting things that can be developed in virtual production space. And I think that it's really cool that companies like Voltaku are looking at that and saying, how is this going to change, and why can I, let's not rely on the legacy and let's look at the future in some ways.
I think we did get a question through. What video card is better than a 3090?
The one I have. I
But
got
can't
two
tell
of
you
them
about
too. They're A6000s that I'm using right now, which is basically a 39, except it's got twice the video memory. Each one of them has 48 gigs, and they can be live linked, or they can be NV linked together. So it actually gives you 96 gigs of video memory, which is that's enormous amount of video memory. But yeah, it's really great. It's great.
And there was another question. Can you share the shopping list so we can build our own cameras?
I actually have to ask Justin about that, but it's not that complicated. Listen, you guys, there's a monitor. The monitor is battery operated, so you need a battery for the monitor, and then you just get some kind of Miracast thumb drive thing that exists everywhere. It's just an HDMI connection, a Vive controller in the front, And then these two cheapy, I mean, I think these things like $30. Like, it's just a stupid little controller, and then you just reprogram it. So it's great. You know, you don't have to get too crazy about it. But yeah, it's really cool.
And one more question. Do you use shortcuts for Vantage?
I don't actually use shortcuts because I honestly the only thing I'm really using Vantage for is for rendering, right? So I don't actually most of the data is coming actually from Unreal. So Unreal is pumping all the data. So all the exposure controls, all those things are being controlled in Unreal. But then Vantage is just rendering what is actually being done in Unreal. And I want that personally because Vantage actually has the take recorder. So everything that I'm doing in a camera is being recorded on a take recorder, and then I can replay that later, which is kind of the big thing that I want to do as well. So I've got lots of ideas where I want to take this beyond that, but the take recorder inside of Unreal is actually a real advantage.
Nice plug. Great. That was a wonderful presentation. Thanks, Sally, for joining us. Really appreciate it. You're
Yeah,
a
thanks for having us.
long-time friend of Chaos. We always love having you at events like
Yeah,
that.
and she's been on, you know, I know I keep plugging CG Garage, but she's been on CG Garage like 3 times already. So please check the cool thing stuff out. And she's been exploring some incredible technology. Always check out what Sally is doing. Follow her on Twitter. She's doing some really cool stuff. What's your Twitter handle, Sally?
Oh, it's Sally Danger.
Awesome.
You know, just my legal name.
And there, right behind me was your number one fan. She just passed by.
Fruity nerd. Tell her hello.
Yeah, fruity nerd. Yep.
Wonderful.
Awesome.
Well, thanks so much for having me. It was a pleasure, and it was, of course, a blast. You know, hosting your mad scientist amazingness on the Killtopia shoot itself. So, thank you so much.